Hi, everyone. Welcome and thanks for tuning in to our last and final day of the 2021 Virtual Landscape Faculty Academy webinar series. This is the Fundamentals of Two-Wire Systems webinar. Before we get started, I would like to take a moment to thank our sponsors, Rainbird, Hunter, Ewing, and Brightview for making this event or for helping make this event possible. Some housekeeping notes. Everyone is muted, so we won't be disrupted by latecomers. Please keep your microphone muted throughout the entire presentation unless you have a question. During the presentation, if you do have questions, you can ask verbally by unmuting yourself and asking our speaker, or you can write in the chat box if you prefer. I will be monitoring the chat box throughout the entire presentation. Without further ado, please welcome our speaker, Craig Borland with the Toro Company.
Thank you very much. Now I have to go and redo that. Excellent. Welcome, everybody. I believe this is most of the folks that were with us on Wednesday when we did our forum. I appreciate you guys coming back. This is a 1 hour, very quick, abbreviated session on two-wire. What I want to focus on is the fundamentals of two-wire, how it works, why it works, what makes it not work. There is a section on troubleshooting in here. My focus this morning wants to be somewhat about two-wire and the technicalities of two-wire and the fun and the not so fun of two-wire. And I have some pretty photos that are in the presentation on some lovely, oh boy, pictures that I have encountered along the way. So it's going to be a presentation. But as I mentioned on Wednesday, I have my camera, I have show and tell on my table, and I'm going to try and give you an idea of how using a secondary camera, and my third camera decided it wasn't going to cooperate today, so I've put it in the corner with the hat on it and said, behave yourself over there. So what I have is going to help maybe some of you folks to look at maybe integrating some of this if you do a virtual class instead of in person. But nonetheless, that is my intent. I messed not saying at the beginning. My name is Craig Borland. I've been in the irrigation industry for an extremely long period of time. It's kind of embarrassing to say, but nonetheless, I started with a small manufacturer, 1978. I did field service work for them. All my life in this industry has been technical, and that's what I absolutely thrive on. My father was an electrical engineer. He wanted myself, my brother, to become engineers as we grew up. My brother chose pharmacology. Good for him. I chose plants. Not so good for me. But quickly into my career, I said, Dad, I need to get my voltmeter, oscilloscope, and soldering iron back. He goes, now, why would you need that for plants? Well, they have sprinkler timers, and somebody's got to fix them. So hence became the beginning of my technical aspect of this industry. I eat this up. I love this. I support the engineering staff of my current employer, Toro. I support the marketing department with field input and understanding of what happens when they break. And that's one of the things that, as a child growing up, I learned very well on how to understand, okay, it's broken, got it. What broke it? And that's the fun and challenge of troubleshooting. So troubleshooting is one of my favorite aspects of the industry because every troubleshooting issue is a challenge. And with all challenges, there is a golden opportunity or the golden reward of finding the solution. More so, being able to convey the process of getting to the solution and being able to get it to work with people doing it in the field. Now, being instructors yourselves or in that level of capacity of some sort, how do you stick to these folks after a training class or after the session? That's a difficult challenge that I have myself in the trying to get this information that I'm conveying to stick to the student. Not so easy in many cases, but let's see what I can do to help you utilize what we have here to do the same thing. So without further ado, let's begin. Two-wire technologies. And my computer is being, hello, wake up computer. Oh, nice. Now it wants to cooperate. Okay. So, a little ditty on the IA. That's, we don't need to even belabor this too much, but the Irrigation Association, guys, the Irrigation Association is one of my go-tos for information. all kinds of information on the IA website, resources, an incredible list of resources, books that I've helped write, books that others in the industry, leading industry experts have helped put together. There's just a myriad of good information on the website. So what am I going to cover in this 50 minutes of time here? Two-wire systems, what they are, what makes them different, what's their advantage, what's their disadvantage, how can people apply it to their business offerings, design basics, what makes it different than conventional systems, and some of the nuances about that that may need to be carried over. And then there's a section on troubleshooting towards the end, which predominantly is what people, when they come to a two-wire course, that's pretty much what they come to learn. How do you solve the two-wire riddle? Because there is a lot of two-wire out there now. Just about every manufacturer is making it, and some are different than others, but many of them are very similar. But there's some nuances about them that people don't quite fully grasp when they're installing it, leading you to all kinds of complications, difficulties, or misconceptions. Because the phone calls that come to me predominantly start out, your stupid adjective product isn't working. So I find the time, meet them at the property, and spend probably about 20 to 30 minutes looking at what's going on, doing some quick checks on this. I say, product working just fine. It's in the field, which means it's not my problem, not my product's problem, but how the system was installed. So that's part of what I really want to bring to the forefront, aside from all that other stuff. So there you have the basics of the agenda. What I hope that you walk away with, this is my report card. Whether I achieve it or not is going to be told at the end of the class. But I want you to understand what a two-wire system is. I want you to walk away with some basic understanding of what a two-wire system truly is. I want you to understand there are differences about a two-wire system as opposed to a conventional irrigation system, and some of the design aspects that are different between the two. I would like to show you how to take an accurate amp reading, or explain to you how to take an accurate amp reading, because when troubleshooting two-wire, there are two basic failure modes that you will encounter. And one, you can use traditional methods of troubleshooting. The other, you will have to take amp readings to see what the true amperage draw is. And we'll get into that as we go further. And last but not least, I want you to understand and be able to troubleshoot the two-wire system, putting it all together. Now, that's my report card. We'll see if we get there by the end of the session. Again, only an hour or so, going to be quick. So, and as always with the Irrigation Association courses that we have put together, we rely on our manufacturers to provide us with product. I guess the best way to put it is for free. We're looking for donations from different manufacturers. So the products we put in these classes or show on the slides are products that were donated to us from different manufacturers. By no means are we trying to emphasize one over the other. In this session here, I would normally not say who I work for, because I want people in the class to see it unbiasedly. I want to teach the class unbiasedly, so not one product is favored over the other. Of course, so that's my disclaimer here. Now, as I began, everyone seems to be in the two-wire craze. Toro, Rainbird, Two-Core, Flowmaster, Hit, Baseline, Hunter, Acclima. There's a lot of different variances between all of them. There are some nuances we want to discuss, but for the most part, two-wire is predominantly just what I said. It's a two-wire system. They've been out for a while. The first system I worked on, made by John Mansville, which is now part of the Buckner Western Brass group of companies, but nonetheless, it was out in 1966 when it product first came to market. I didn't start working on it until the late 70s, but it was a four-wire device. Two of the wires brought 24 volts out to turn things on and off, and two wires brought out communication to each and every one of the little modules that they had in each of the valve boxes with the valves. So it really wasn't a two-wire system per se, though we still refer to it as such. In 75, we started seeing used quite heavily in golf courses because the best aspect, or one of the best selling points of two-wire, is you could splice into it and add on to it without having to run wire all the way back to the irrigation controller. So when a golf course had the 18 holes and they acquired some property further down and could add another 9, tie in and just add on to it without having to run wire all the way back to the closest controller. So that provided a great advantage, and that's why golf courses were the ones that hopped on this first. But they were susceptible to some issues back then. Back in the 70s or late 60s, I'm sure you all understand our technology was not as the same level that it is, I would say, today. Back then, our communication on line or wires was a little unstable, prone to different issues that could come along the way. But one of the key disadvantages of two-wire was if a lightning strike hit, if a power surge hit, or if for some reason a decoder decided to give it up, it acted like Christmas lights. I'm not sure if you guys are familiar with Christmas lights. When you got one LED light bulb on the string, the entire string was burnt out. And you had to go through the staking process of pulling a bulb out, putting a known good one in. That didn't fix it. Go to the next slot, and work your way throughout the whole string. Well, that's what you had to do with two-wire back in the day. Now, we have found a way not to have to go through that, and we'll talk about that some more as we proceed. So here is a great photograph of one of my original units I've encountered. This one dates back to 1966, as I said, and it's a mechanical clock. And when you talk about mechanical controllers, the majority of the industry understands those were pretty simple. You've got your hour dial, see if my mouse will work, hour dial down bottom left corner, little metal rings. You rotate or just push the ring inward. Actually, it was pull the ring outward. It would trigger a switch to turn the system on at that particular hour. There was a spot at midnight here that would turn the day wheel. And if you notice, the day wheel had 14 days on it, so you could do every other day. It made it work. One thing that was nice about this one is here's your midnight mark right there. You could move that so that the irrigation system could begin at like 10 at night, continue past midnight without the day change, and have it continue to water. Because when the day changed, if you look down at this day wheel, there's a screw in for each day. And if that screw is pushed in, it activates a switch to make that day active. Well, we all know at midnight, typically our days change from one day to the next. Today of all days is lovely Friday, which won't be Friday for me until 4:30. Well, in case it becomes Friday. But the problem with midnight changing the day wheel, if that screw is in activating switch and tomorrow's not an active day, the system would stop watering at midnight. So that's how and why we gave you the ability to move the midnight around. Nonetheless, your station run times was a matter of pushing a pin in the right minute slot. If you look carefully, we got a program A, we've got a program B, so we can have some water some days, some water different days, and your different run times on there. All that's pretty simple. I like this because I've heard manufacturers claim they were the first ones with water budget in the 80s and 90s on their clocks. Here you're looking at the original water budget. This takes your schedule and either multiply it by 1, by 2, 1.5. It was its very first version of water budget. So water budget has been around a very long time. So I got to say that. Now, everything's simple, straightforward, except for this nightmare on your center right where all the little black wires are. That's how you assigned nomenclature to each of the decoders, or what valve each decoder was. And I'll get into that just a bit. Not simple, but yet simple. So back to what we're talking about, decoders. They are an alternative to traditional control systems. They work much like an irrigation controller in that they turn things on, they turn them on for a length of time, they turn them on certain days of the week, and that's what a simple control does. In essence, what is a sprinkler timer? It is a programmable switch. Turns on at 6 in the morning, runs that light for 15 minutes, and then it goes to the next light. And it's a programmable switch. That's all a controller is. Well, that's all a decoder is, in that it's a controller that's located out in the field. And it gets its activation time from the main control product, which is back at the facility somewhere. Decoders are simple and reliable. They're switching devices. They work just like a conventional controller. The key takeaway is that they're all interconnected on a single 2-wire path. It can be 2 or 3 different 2-wire paths, but they're all tied together on this 2-wire path. That 2-wire path is for true 2-way communication from controller to decoder. Hey, decoder, turn on station 14 for 15 minutes. Boom, it turns it on. It replies back to the controller. Station 14 is running. Everybody's good. Nowadays, they are using decoders more than just for turning on sprinkler valves. They can be used for weather stations to bring data from a location out in the middle of the grass that tells you about the level of sunlight, how much rain you've had, how much wind is going on right now, what is the actual temperature going on, what is my humidity in the area. They bring all that data into the controller, and it will adjust or modify the irrigation system utilizing the ET data, evapotranspiration data, that is brought in through the weather station. You've got decoders that will bring information in from a flow sensor. I love flow sensors. They are an insurance policy because they are designed to shut off a system that has too high a flow. It learns the flow. It's supposed to be 30 gallons a minute on that zone. A broken sprinkler head occurs. It now jumps to 50 gallons a minute on that zone, and the clock goes, hold on there. That's not what I'm expecting. That's way too much. Shut that zone valve down, and let's go to the next system on the next zone on this system. Zone 15 turns on, flows good. It continues on its way, but it sends an alarm back to the controller saying zone 14 has a high flow condition. I skipped it. So the person managing the system would either get an email, a text message, something would show up on his phone to let him know an event has occurred on the property. You need to go check it out. And in this day and age, with technology the way it is, I'm sure each and every one of you folks here in the bunch, you all have a cell phone. I'm going to say without a doubt, I'm going to go as far as to say 99% of you all have a cell phone. I like to call them adult pacifiers because anytime you have a moment of time to spare, you're playing with the cell phone. I know that. Your media, your host of people are on that cell phone waiting to talk to you or text you or talk to you by writing something. But here with technology, I can have my system send me an alert that something has occurred on the property. That is cool. Now I'm proactive instead of reactive to the issue. In days gone by, I would have a broken zone 14. I would have a geyser going. I wouldn't know any better until somebody saw it and called somebody and says, hey, Frank, we have a beautiful fountain in the middle of the turf grass. Now, fountains should be someplace to go and enjoy, but they're not supposed to be in the middle of the turf grass, especially when it's supposed to be irrigating. Somebody's got to go check it out. That's the old way. Well, nowadays with technology, we can get alert that there's a fountain going on. We need to go address it. And that's one of the benefits of having a 2-wire system with a flow sensing type decoder out there. We have moisture sensors we can connect to a decoder. So now I can determine it's too wet or it's too dry in a specific location. And I can adjust my irrigation schedule to modify or account for that moisture differential out in the field. So they're not just for turning on zone valves. You can hook them up to these devices and more coming. Also, they can be a single solitary standalone system, or I want this clock to operate this specific park. I want this clock to work this specific commercial building. I want this clock to work this specific right of way. It can be one clock or it can be tied together as a central control where I've got a computer that talks to many clocks, which talk to many decoders, which, okay, and so on and so forth. They tell two friends, like the old commercial. It's a really versatile system that we can work with. Standalone central control, it can be a complete new system, all brand new being put in. It could be modifying something that's already there. Like I said, you could tie into it and add on to it, which is great. But if you're going to start and add on to a system, please be careful. If you're going to try and use existing wires, it is so very important to somehow, some way, and it's another course that we teach, validate the integrity of the existing wire to be good. Because if there's any deficiencies on that wire, weakness in the insulation, cracked insulation, leaking to earth ground because some subterranean mammal has nibbled on the insulation. I mean, gophers, ground squirrels, creatures that burrow, they can get after wire, because what's the difference between a wire and a tree root to a subterranean mammal? There isn't any. They'll chew through either one of them with no manage to themselves. They'll go right through it. So watch out for the add-on. They have advantages that we've mentioned. They have disadvantages that we'll get into. Less wire, because you're only running 2 wires to all these control valves. In the days gone by, a 60-station controller would have 60 cables for each of the wires feeding the valve. And then they have a common wire that goes among all the valves back to the controller. So essentially it's 61, 62, maybe 70 wires going out in the field. That's a wad of wire. But with a 2-wire path, you get 2 wires to go out to all of them. So it is a lot less wire. The ability to add on, but not indefinitely. It does save wire. However, decoders, they're not inexpensive, and wire connectors are not inexpensive. So there are some things that we'll talk about here briefly. Time is running short. So here's an example of a simple system. You got your sprinkler timer there. You got your 2-wire path. I need you to pay careful attention here. If you look closely, there's a blue, there's a black wire feeding that 2-wire path. So what does that mean? There is polarity on that 2-wire path. You've got a hot and a common, a hot and a neutral. Why is there a polarity? It's AC wire. Understood. However, we are now using 2 wires, just like the phone company does currently. Well, now, because we got cell phones, we don't have wires. Back in the day when we actually had telephones wired up, we would have 2 wires feeding the phone. You'd have 1 wire for communication, 1 wire to make the bell ring. And back they all had 3 wires because there was a return path to them. Many of them just went to earth ground. But Ma Bell, in her infinite wisdom, provided us the technology to have a power wire, which is our 24-volt line now, and have DC logic embedded on that same wire. So in essence, I've got AC power turning valves on and off. I also have a DC communication on that same wire path talking to the decoder and having the decoder return that communication back to the controller. So very ingenious. We just use that same technology here. So here we've got our controller, the little brownish colored box on the top left. We have our blue and black wire feeding to these little round cylinder looking things, which are decoders. Note that each decoder can be spliced in anywhere. And at the very, very end, you have a decoder. So never leave a 2-wire path sitting in the dirt. Have it dead end or finish its run at a decoder, a surge device. Never have the wire exposed to soil. Here is the key reason. That 2-wire path has to communicate to every decoder on the system, every one of them. What does that mean? That when I go to turn on station 14, the decoder for number 14 says, I got the information, thank you very much. It turns on 14, it's working like a champ. Every decoder on the system hears that communication. That 2-wire path has that voltage flowing on the entire path while zone 14 is running, which means that 2-wire path is live. In many cases, that 2-wire path is live 24/7, 365 days a year, including holidays. It's running all the time. For in effect, if you had a moisture sensor, a flow sensor out in the field, and the flow sensor detects unexpected flow, hey, that valve all of a sudden decided to turn on accidentally. The flow sensor would tell the clock and the system would shut down. So the 2-wire path has to be live in many cases all the time, which now means there's power on the wire all the time, which also means if there's any compromise in the insulation, it can be leaking to earth ground and bad things can occur. So that's kind of it in a nutshell, what makes it so unique. You've got a clock, you've got a 2-wire path. It feeds these things that are labeled here as a decoder, and it goes out to all the zone valves. Whether station 1, station 48, the same 2-wire feeds each and every one of them. Each decoder says, nope, I'm not 14. You go turn on 14. So they're all listening. It's like being in a room like our classroom here, and I look out in the bunch and I see Nicole's name there, and I go, hey, Nicole, I need your help with this thing. Turn on zone 14. Well, Janine's there, but it's not pertaining to her, so she does nothing about it. So it's kind of like a controller calling out somebody in specific to have them to do something. So it's kind of cool how that works. You can have a combined system where it's conventional, and you can add on using 2-wire with some other product out there. So it does give you versatility. On a conventional system, here is a sports park. I got my polo, I got my soccer, I've got my baseball field, I got 3 controllers with 48, 50 zones on each one. That's just a wad of stuff. If I were to convert it to 2-wire, oh, that is so much cleaner. I got one clock feeding the baseball, the soccer field, and the polo field. And if the cool thing about 2-wire, if the wire that goes off to feed this polo field in top left-hand corner, if that wire were to get severed, cut, or eaten through by a creature, the baseball diamond and the soccer continue to work. So where the wire path has been cut, it stops working from that point forward. So when you go to troubleshoot it, find where it's working, find where it's not working, and look somewhere in between to find the broken wire, which makes that relatively easy compared to that of a conventional system. Looking at a parking structure, yes, you've got a lot of water, a lot of wires feeding each of the planter beds. That's just a nightmare, and it's an opportunity for trouble to come in. But when you're looking at a 2-wire path, so much easier, so much cleaner to go through the whole system. A highway project, conventional, lots of wires, 2-wire, just 2 wires feed the whole thing. It works so much better. So yes, you have long wire runs. In some cases, up to 3 miles away, depending on what brand you use. 3 miles away. That's a significant distance. It's just 2 wires to interconnect all these decoders. So it's a lot easier, a lot cleaner. However, you have a lot of connections. You've got a lot of decoders. The savings are multiplied on sites with longer runs, and it's less wire. So I'm going to say yes, in some cases, it can save you money. The question that comes to me often, Craig, where's the break-even point on this? I'm going to say with all the different products that are available, it seems to be right around 36 stations. 36 stations and under conventional systems are probably financially better. 36 stations and higher, 2-wire is less expensive or more of a benefit for cost factors. But it's still also, what are you comfortable with? What one do you feel most best putting in? So where the break-even point isn't necessarily as critical to understand as it is to understand what are you most comfortable with? What are you going to be able to go back and service? All these things play into account for which system works best out in the field. Decoders, they're fully waterproof encapsulated devices. Underground in the valve box, out of sight, out of mind, less prone to vandalism, makes them very, very effective for that device. The decoder has extremely low power consumption to it. So it's not drawing as much electricity as a conventional system could very likely do. So yeah, you're going to save some money on energy. It's not significant. So I wouldn't hang my hat on that as being too radically important. Each decoder has a specific name to it. Many of them require you to assign the name to the decoder, which means you got to sit down and tell all these decoders, all right, what zones are you working? What zones are you working? What zones are you working? And you use an indelible ink marker to write on it what zone it's supposed to be. Great for installation, great for putting it in 5 years later. Even if it's indelible ink, they tend to fade or disappear. So it's best that you keep a track or keep a paper copy of what went where, in case you have to refer back to it time down the road. Many of these decoder programming devices can be used to see, is the decoder a good working decoder when it comes to troubleshooting? So there's a lot of different aspects to it. Hunter has a great device to program the decoders. It's a handheld device. You can walk out in the field and program the decoder. You can plug it in and analyze the decoder for its functionality. But I have to stop at this moment. I need to convey this critical bit of information. Hunter only works with Hunter. Rainbird only works with Rainbird. Toro only works with Toro. Weathermatic, only Weathermatic. Baseline, just Baseline. A climate, so on and so forth. So yes, that programmer is very convenient, very handy, but it only works with the one brand. If that's all you have, and you're doing strictly the maintenance on this one site, excellent. If you're out there doing troubleshooting and working on multiple sites with different product out there, not necessarily the best product to have for troubleshooting. For programming, oh, it's a great handy device. However, again, it's specific. And that's the key takeaway from two-wire systems. You've got 50, 75 stations out there with 50 to 75 decoders. They're all Hunter decoders. Guess what? They only work with Hunter controller. If you want to change a controller, you'll have to change all the decoders to match the brand the clock is. So that makes it somewhat guaranteed that what goes in as Hunter remains as Hunter, what goes in as Rainbird remains Rainbird, what goes in as Toro remains Toro, what goes in as K-Rain remains K-Rain, that they're brand specific. What valve is used, what sprinkler valve, what sprinkler heads are used can be anybody's, but the decoder must line up with the clock. Programming decoder, pretty simple. Note the color of the wires, red and blue. There is polarity on the communication part. Plug it in, the clock says, oh, sure enough, I have a decoder. What am I going to do with said decoder? It's a 2-station version. What zones are on it? How much voltage do I need and how much amperage do I need to turn those solenoids on? The inrush is what turns the solenoid on. If you have high water pressure, you need an inrush factor of 5. If you've got high water pressure, you need the higher inrush. Along with that, you would also need to have your power factor set to be able to handle the high water pressure. So that here's an example how you can adjust the power consumption for each decoder. You send that information. Sure enough, it looks at it. We're good. Decoder's got that information. We're talking. Everybody's happy. So it's a process that must take place. The big thing to understand about two-wire, if you got a conventional system, 24 zones, it might take 15 minutes to program all 24 zones. But to do a 24-zone two-wire system, you got to program each of the decoders. Then you got to go to the clock and tell each decoder it's in there, and each decoder is going to run certain stations at certain times. It's going to take you a considerable more time, a lot more time to program a 24-station two-wire than it is a conventional system. So there's more labor involved. And with that aspect, what's the most expensive part of an irrigation system? The labor. So we have to be careful with the labor aspect of it. Wire connectors. Two-wire typically has higher voltage, so it can feed up to that 3-mile wire length. Many of the two-wire pass voltage ranges from 35 to 40, in some cases higher than 40 volts, but each solenoid valve works at 24 volts out in the field. So it's a 24-volt system. Though the two-wire path is higher voltage, you must use a specific wire connector rated for that higher voltage. Your average everyday wire connector, like you see in the photo, is not suitable for the two-wire connections. You must use a device like this one, where it's a brown in color or light blue in color, which has the voltage rating on it for higher voltages. There is a huge problem with people out in the field where they use the wire connectors and they're not the proper voltage. Does somebody have a question? No? Okay. So when looking at the setups, Page Electric was kind enough to share this photo. The DBY on the left is a conventional wire connector for any old connections out in the field. But for 2-wire, you must use the DBY-6, which is the brown or the blue colored. It's rated for the higher voltage. King makes them. Other brands make a higher voltage rated connector. Make certain they use a proper voltage connector. Second, when you're using a waterproof connector, make certain the insulation of the wire goes into that connection to waterproof it. Electrical tape, as you can see in the photo here, is not a suitable waterproof connection. It leaks. Look at the air pockets where the adhesive used to be. When doing wire connections, we need to keep in mind, you got a 42 station system or 40 stations out there, as this says. How many splices will you need to be able to get station 40 to work? It really depends upon how many splices you have on that field common wire from the clock to station 40. Of course, you have one connection for the hot wire, but you may have 38 connections. You might even have 40 connections on the common wire feeding station 40. So I'm going to say most likely 41 or quite likely less than that. When it comes to 2-wire, same scenario. However, please note in the photo, I have a wire connection at decoder number 1. I have a wire connection at decoder number 2, 3, 4, so on up to 40. So now how many connections will I need to get station 40 to work? I'm looking at 82, 80 more, or more. So you've doubled the wire connections. Number 2, that higher voltage rated wire connector is more expensive than the average wire connector. So now I'm spending more money on a connection to do my wiring up to the furthest zone. What about the cable? You have twisted pair, you have twisted pair in a sleeve, or you have parallel wire, meaning it's flat. Hunter Tor like the twisted pair in a sleeve, Rainbird, Rainmaster, many of the others like it flat parallel. What's the difference between the two? Well, one's twisted and one's flat, which means that whenever you got wire path and you have communication on the wire path, there's going to be a little bit of noise generated on that 2-wire path. So you'll have a magnetic frequency that's given off from it. And if any other wires in the neighborhood, they can pick up that noise, or any wires in the area, you can pick up the noise. Typically, a twisted wire will have a more shallow or more tighter magnetic field to it. So it's going to be a little more protected for picking up stray signals than a flat parallel pair. But the measurable difference between the two is insignificant. So I'm going to say whatever's specified on the property, that's the wire to use. But there's your example of what the types are. Here's a twisted pair going out into the field. You have your twisted pair wire. Note the wire connectors in the center. These are the brown colored ones. That's the higher voltage rating because this wire path has 33 volts on it. I can use a conventional connector after the decoder, which is this little brick right here. And I have my 2-wire connection from the 2-wire path to the decoder. And then I have my valve connection here. So I can use any connector here, but this must be the higher voltage connection. You can have a big system, and it brings up the question, what about grounding? Well, every manufacturer has their own recommendation, but on average, they all say to put a ground rod roughly 500 to 600 feet from one spot to the next spot. So every decoder, 500 feet to the next one, you need to have another ground protector or a surge protector. Every 500 to 600 feet, you put a lightning rod, a ground rod, and a lightning arrestor or surge protector. Now, due to time, I'm going to see if I can do this quickly. Hopefully we don't lose anybody in the transition. And I forgot one more button here. As I mentioned on Wednesday, I have a camera. I have my workbench. I have this is a decoder here. It is a brick, about the size of a pack of cigarettes. This is a 2-station decoder. and I don't have a 4-station one here where they'd have 5 wires here instead of just the 2. This goes to the solenoid valve. This is my 2-wire path feeding from the controller. It's red and black, so polarity is important. So this is a decoder. There's another decoder that's tangled up. Here is my surge protector. Just a little round tube measuring, oh gosh, I'm going to say maybe 3 inches long, about the diameter of a thumb on it. Has a green wire for ground, red and black to match the 2-wire path. It's a surge protector, which you would connect to a ground rod. This I need to caution because this is where the trouble will come in, because these things can short out in the event of a lightning strike or a high power surge. This will short out. When it shorts out, it creates a short on the 2-wire path. You need to go out and find where the problem is. While I have the picture here, these are what we call clamp meters. This clamp meter is as you can barely see if I can get it to show, on the very bottom, lots of glare, it says leakage tester. It says leakage current tester on it. This is the kind that you need for 2-wire testing. This is an average clamp meter for measuring amperage. We're dealing with milliamps, which are very, 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 very tiny amps in the system. And that's what makes it very difficult, because you have to have that specific, where did it go? There it is. You have to have that specific device to measure that little amount of current. The milliamps, they're very small and they're hard to read on any conventional meter. The clamp meter that I use, roughly about $250, $300, depending upon where you get it, is the best test device because it works on every manufacturer's system. It works on every manufacturer's product. Whereas the device we use for programming works for their decoder, but it does not work on other brand product. And I am really running short on time. Noting the different grounding techniques every 500 feet. You can go to the furthest decoder, furthest system, 5,000 feet on this particular brand product. Again, they want a ground rod at each decoder, or roughly 500 feet away. I know it says 5,000 feet to that decoder, but there's nothing in between, so the ground rod can be at the decoder 5,000 feet away. This company here says to use a ground plate instead of a ground rod. That's a little more expensive. But again, it's all about the level of protection you're trying to achieve with this ground. If you're in an area of, oh, that's a beautiful picture. Never mind that one. That's a little better. This particular brand also recommends a ground plate, but they also say run a ground wire to each and every ground line. That's a lot of wire out in the field. Either way, follow the specifications for the manufacturer you utilize. And in doing a ground, setting up a proper ground, don't be this example. First of all, that's not an appropriate ladder. Second of all, holding the ground rod like that with a guy in a sledgehammer, that just looks like an opportunity for something bad to happen. And oh, by the way, 8-foot, 10-foot ground rods need to be 8 feet to 10 feet away from the thing you're protecting with the ground. This here is like 3 feet away from the power pole. That's not the appropriate location for the ground rod. That ground rod is definitely too close to the pole, not appropriate. Because of the influence, the sphere of influence, what I mean by that, it's the dissipation of the surge. I got an 8-foot ground rod. I have an 8-foot area I need to have clear so it can dissipate the power surge to earth. You put two together, they need to be 16 feet apart minimum, whether it's an 8-foot rod or a 10-foot rod, so that you don't have them circling back up on top of each other, causing it to not perform its protection. Ground plate, the sphere of influence, predominantly on the lead in or the moving away from, not side by side. Because lightning can occur. And with NASA, you think these folks have the most sophisticated, the most expensive grounding process out there, and yet lightning still got the target. This is what should have happened. You hit the lightning rod, everything should have been protected. So grounding is important, especially in high lightning prone areas, because this can occur. It's not good in any sense. That is not good at all. So proper ground rod away from the ground plate, make certain your sphere of influence is taken into account and that you're doing your proper grounding away from what you're trying to protect. All right. Now, I've got essentially 16 minutes to go through troubleshooting. This is a lot of photos. I'll try to go through quickly, but in troubleshooting, we have to eliminate what it isn't to find what it is. We need to know the difference between symptom and cause. Symptom are misleading. Symptoms make you think, oh, that's the problem, fix it and let's move on. I cut my finger on a sharp edge corner of the cabinet. I put a Band-Aid on the finger. I fixed the bleeding problem, but I have not replaced or taken care of the sharp object. I fixed my symptom, bleeding. I didn't fix the problem, the sharp edge. That's what we're looking at in troubleshooting. And in two-wire, you have predominantly two major issues to contend with. Short circuit, high current draw, which either burns a fuse, blows a circuit breaker, or melts the clock, which is definitely not bad, not good. I mean, that is definitely bad. Or you have a no communication symptom. I'm trying to get station 14 to turn on. Station 14's decoder does not respond back, so I call that a lack of communication. What causes that? A broken wire or a bad wire splice. So you're working with either one or the other, a high surge, a short circuit, high current draw. You need to either do old school amperage, old school ohm check. If it's a no communication, that's where you're using your milliamps and you walk around to see, do I have power here? Maybe my decoder has lost its ability to communicate. So these are two functions in a nutshell, what we're trying to go after. The most common issue, without a doubt, hands down, compromises on the wire insulation. Somebody cut the wire a little too heavy with the knife, using the wrong style connector. If you look on the inside of that wire, there's green there. Well, that's oxidation occurring on the wire. The wrong connector, the goo overheats and comes out of there, and it's no longer a waterproof connection. Using a proper connection is paramount to the system's longevity or working reliably. These are just examples of bad wire connection. The insulation is not in the connector, so there's no waterproofing there. Somebody used pliers to pre-twist it and broke the wire. This guy, I don't know what to say about that. A Rubbermaid tub with wires in it, and they took a can of PVC glue and poured it in there. Said, hold it, don't do that yet. Let me get a picture of that. And then they poured the glue, and I go, that's the most ridiculous thing I've ever seen. How are you going to replace that? Well, you're not. Because corrosion can occur, and when a corrosion occurs on the wire, it breaks. The copper essentially dissolves. And now that's where I took my thumb and forefinger and grabbed the wire, it came right out of the wire connector. It's definitely not good. So following the path, when you're doing troubleshooting, try to establish a process to go through. Do I have power at the source? Yes, that's not the problem. Do I have power at the transformer? Yes, it's not the problem. Is the controller working? Yes or no. Controller works fine, then it's in the field wiring, or it could be the solar. Follow the same sequence. Never skip a path. Using the clamp meter, as I mentioned, very important. There are many different types of them out there. Whatever one you use, it just has to be a leakage current type device. It's specific to it, leakage current. Underhill makes them, Armada makes them, X-Tech makes them. This shows Meterman, X-Tech bought Meterman, Fluke has them, many different companies have them. How do you use them? You measure the amperage on one wire, because you're measuring the flow of electrons on that wire. You put the two wires together, you got the flow of electrons going to the right, and you got the return path going to the left. That essentially is 0 ohms moving on that wire. They contradict each other. Using this device, great. Goes out, checks the decoder. Hey, this decoder is not talking. Time to put a new decoder there. Excellent for if it's a Hunter one. But if you do multiple brands out there, your clamp meter is going to give you the exact same information. But your clamp meter can be used on anybody's product. That's the key takeaway. So knowing that each decoder, whether it's Toro, Rainbird, Hunter, K-Rain, Weathermatic, AC decoders predominantly have a 2-wire voltage of 33 to 50 volts, and the decoder pulls or draws 0.5 milliamps. A 4-station decoder, 6-station decoder. Rainbird's got some of those. 1 milliamp on there. When that decoder is activating a solenoid itself, then the 250 milliamps on there, which means it's a solenoid and the decoder. But as I said before, when you turn on a station, all the stations have information being sent to the decoders, and each decoder says, okay, that's not me, I'm not turning anybody on. So you still have the voltage, you still have the current draw, and each decoder is going to draw that 0.5 milliamps, regardless of it turning anything on or not. So when it does turn something on, you have 250 milliamps. There is a DC system out there. There's a couple of them. They're very similar. Their decoders pull 0.6 milliamps. Well, 0.5, 0.6 milliamps, that's the same. The AC is 33 to 50. This one's 40 volts. Essentially, at this point, they look the same. It's what the decoder does to the solenoid that makes them different. So 0.6 milliamp, that is a good decoder. 5.96 milliamps, that is a bad decoder. So you can do this, and if you're looking in the pictures and you're following along, there's a huge, huge benefit. My clamp meter does not require me to separate any wire connections. I'm not cutting any wire. I'm not removing wire splices. I just clamp around the wire, feeding the decoder up in the top of the screen. Or I'm taking that clamp meter and I'm clamping it around the 2-wire path in each junction box or each connection box. I'm not disassembling anything. When I'm looking for a high current draw on a decoder, this is a bunch of deep knee bends bending over into a valve box, but I'm not cutting any wire. So coming back to fix all that is very simple. I walk my wire path. I'm going to be walking 2,000 steps to find where the bad decoder is. And sure enough, I found the bad decoder, 5.96 milliamps. That's the bad one. You need to replace the decoder. Everything's going to be good and dandy. Fine, works like a champ afterwards. So there are many classes being taught today. Manufacturers teach them. Independent organizations teach them. People like you folks teach them. There's many different classes out there. What I have learned by troubleshooting 2-wire for the past, I'm going to say close to 20 years. Some are more recent, a lot more of them nowadays than I have in the past. I have found clamp meter usage is great when I have a high current draw due to a bad decoder. But if I have a direct short in the wire path or a decoder's gone bad because it's shorted, I'm going to have to start taking wire connections apart to find that one. They get more complicated, they get more time consuming. So, troubleshooting. Using a clamp meter makes it quick, simple, easy, but it doesn't always work on systems. There are people out there that say, use a lighting transformer, put a solenoid on there to eliminate the draw. I've tried that trick. It kind of works. I just find that it's easier for me if I have a direct short, do the ohm check, and I'll get to that in just a moment. There's another high current draw, 1.82 milliamps. That's the bad decoder in that picture. So what am I doing? I'm walking through the line and I'm checking wires in each valve box. 0.012, 0.25, but the 0.25 is a high draw. It's not there in that system. Work your way down the line. And you just keep moving down the path, opening valve boxes and look inside and checking each one. Start at the clock. 225 milliamps, that's a current draw that's excessive. That's a problem. Where's the problem? You just have to walk the field to find it. Go to the first junction box, 813 milliamps. I know that's a problem. Where is it? You just have to work your way through. If you look carefully in the bottom of the picture, you'll see there's my surge pill there. And down the road, that's where my problem was on this particular scenario, nonetheless. 232, I'm getting closer. And then boom, there it is, 5.96. So troubleshooting, it's a matter of using that meter. As I said before, wire connections. I can't stress the wire connection has to be specific for 2-wire because this can happen. That was a cracked insulation. Moisture got there, oxidation occurred, corrosion occurred. My copper wire is no more. There's another example, same scenario. By all means, first thing to do in troubleshooting, utilize the controller's troubleshooting diagnostics first. Let it tell you what it has a problem with. So That's the first thing to do. Number two, check the wire connections. Look in this photograph. Where's the wire nut inside the tube? Barely inside the one to the right's even worse. When you use these things, the wire nut has to be all the way to the bottom to provide the best moisture protection. Why are we worried about moisture protection? Because the 2-wire path in many cases is 24/7, 365. It's on all the time. So you just go through and you look at your connections. This is a properly done connection there. The wire nut is at the very, very bottom on both those connections. This one here was one of my worst case scenarios. That was a nightmare. They had 8 decoders shoved into a 6-inch round valve box, and note the wire connectors are just wire nuts. It's a nightmare. So guys, wire nuts, they need to be good. This one, you can see the plier marks on the wire, twisted so bad, but still yet, moisture got in there. I see the black spot. It's beginning to corrode. So knowing the time, knowing where we are in the time, let me bump ahead, go back a couple here and talk about this last thing. Do you have voltage on the 2-wire path? Is it 30 to 40 volts on there? That's a good check to do. And then worst case scenario, you keep blowing fuses, remove the 2-wire from the clock, ohm check it. It must be an open circuit. If you read any resistance on there, if you got a short circuit on there, you know you got a problem on the 2-wire path. So look for your resistance on the 2-wire path, in which case this one now you're going to go out there and cut the distances in half, go halfway out, go into that valve box, open it up, and check which wire has the short on it and work your way through. So the question I have, I know I only had an hour. I tried to utilize my camera briefly to show you what we have, to show you some stuff, how you can utilize the camera to do it. Do you understand what a 2-wire system is? Grounding, troubleshooting, we touched on each of these things. Do you understand what a 2-wire system is? Was I able to convey that? Were you able to understand how to do an amp reading test? I breezed over it. I wish I could have spent more time on it. I didn't even talk about DC just because of the lack of time. This is normally, guys, a 4-hour class that I abbreviated to 1 hour. So that was what my challenge was. So hopefully I met most of my objectives. Hopefully I got across to you what was necessary so you can understand it. Now, I asked the question of you. With what you saw here, it was a Reader's Digest. It was super fast. It was a Cliff Notes or whatever you guys like to utilize for an abbreviated deal. This should have been, or hope was something to entertain or offer to you the desire to come to the 4-hour session, which we actually have hands-on stuff where I show how to do readings and stuff. I'm going to leave that up to Nicole if we can set something up for you guys. Is there something in this session that we taught today that you might be able to apply to your classes? I will be more than happy to help you apply what we did today to what you guys do. Again, I'm going to offer myself up as a great resource for any of you guys. If you need product to help put your classrooms together, reach out to Nicole. She'll give you my contact information. I'll work with any of you folks trying to help supply you with product for your training sessions. Help put together some course material, share some photographs. I know Nicole got this as a PDF to share with you. So if you want anything in the PDF through the IA, that's between you and Nicole. I want to thank you folks for your time. I apologize for going through it so quickly. I had a goal, I had a mission, I put my head forward, I plowed through it. Was there anybody with a question after we're all said and done? Nicole, did you get anything on the chat?
I have not received anything yet. Any last questions for Craig?
Yeah, I have a question, Craig.
Sure.
I have been wanting to get a clamp meter. We have our campus has a 2-wire system, and I work with our grounds department to take students out there and show them, you know, the basics of what the system looks like.
Yes.
But I've been wanting to get a clamp meter, but there's such a range in the cost of them. And can you suggest like what I know you said that you need to look for certain things on there, but is there something that I need to be looking for so I'll get something that actually works?
Yes. Do you have a local irrigation supply house in your area?
Yeah, we have Ewing here as well as a couple of others.
Well, there's two that these guys have. I saw yesterday a Greenlee milliamp clamp meter. The guy bought it and I looked at it. We couldn't use it because it's not sensitive enough. It wasn't a leakage meter. Here's what I recommend. Write this down. Either an Underhill. My Underhill model is a Center 235, CENTER number 235, or Armada, has a yellow clamp on it, is the Armada Model 95. Those are two commonly found products at a wholesale supply house. Most of them have Armada. A lot of them have Greenlee, but the Greenlee I see, none of them go down sensitive enough to be able to read milliamps to the 0.5 milliamp range. 6 milliamps doesn't go deep enough into being able to read the current draw on a single decoder. So that's my concern. Armada, Underhill, you choose your local supply house, what they have. They're going to cost you $300, $250, right around there. But it's an investment. It's a tool that I would say is more than worth its weight in gold. Did I help you? Anybody else?
Questions?
Nobody else? Oh, gee. It either means I did a decent job and people understood it and I didn't confuse anybody, or nobody paid attention, which I don't have any pictures of people's faces, so I couldn't even see facial expressions, nodding of heads or anything. So I'm at a disadvantage here. This is one of the things I mentioned on Wednesday about virtual classes. I now can see Nicole's face. You know? So obviously you didn't get lost in the bunch.
No.
Thank you for allowing me to do this, Nicole. If things
thank
come
you.
up, people respond to you asking information, let me know.
Okay, I certainly will.
Okay.
No additional questions. I think that wraps up our first session for today. So thank you all for joining in for the fundamentals of two-wire systems, and a big thank you to you, Craig, for leading this great session. Our next and final session of our virtual Landscape Faculty Academy webinar series will begin in 1 hour at 2 p.m. Eastern, which is our recent graduates panel. As a reminder, that session has its own unique link. Again, thank you, Craig, and thank you to our sponsors, Rainbird, Hunter, Ewing, and Brightview. Thank you, guys.
Thank you, guys. Thanks for coming.
Thanks, Craig. Appreciate it.
You guys are all very, very welcome. Good luck and teach these kids. We want them in the industry.
We'll be in touch, Craig. Thank you.
Yes. Take care,
Guys.
Bradley.